Well, hello there. This is Mrs. Sharp, and today we're going to continue our discussion about 2.4 Hess's Law. And I'm going to teach you how you can go about finding those pieces of the puzzle if you aren't given them. So we've talked about how to solve Hess's Law. If we're given equations today, I'm going to show you how, no matter what, if you're not given any equations, you'll be okay. So, 2.4. If no equations are provided for you, you can always use the molar enthalpy of formation of each compound in the reaction to find your overall delta H. Because you should always be able to look up the molar enthalpy of formation. And just as a reminder, the molar enthalpy of formation is the amount of energy required or released when 1 mole of a compound is made from its elements. So we call this delta H sub F. And we showed that looking like this, with the little degree sign up top standing for that reaction happening at standard conditions. So a standard temperature of 25 degrees Celsius and a standard atmospheric pressure of 1 atmosphere. One thing that we haven't talked about yet, but we probably should before we move on too much farther, is that the molar enthalpy of formation of an element is going to be 0. Because if we want to know the amount of energy required to make 1 mole of an element, and it's already an element, then it's not going to require you doing anything, so the overall change in enthalpy of an element will be 0. Alright, so let's look at how this works. Let's suppose that your professor, or I, give you this equation. And the equation is that we have some ethanol, C2H5OH in the liquid form, and it's going to react with oxygen or combust, and it's going to form carbon dioxide gas and water gas. And you're asked to find the delta H of the overall reaction. Well, before you do anything, let's make sure that reaction is balanced. So I'm going to go about that in the following manner. First, I'm going to put a 2 here. I'm going to save my oxygens for last. Looks like I've got 6 oxygens over on the left, or excuse me, 6 hydrogens. So I'm going to put a 3 here, and that gives me a total of 7 oxygens. And over on the right I have 3 total, so if I were to make this a 6, then 1 more would give me 7. So it looks like I'm good. So the next thing I want to do is come up with my pieces. So what you want to do is identify all of your compounds that you have, and you want to write your pieces for those compounds. So I'm going to start with C2H5OH. So, here we go. If I were to write the delta H of formation for C2H5OH, I would start over on the right, and I would write my product, C2H5OH, and that would be in a liquid form. And right off the bat, I would go to my reference sheet and I would look up my delta H of formation of that compound. And according to my information, which I'm finding on Google, for liquid ethanol, the delta H of formation is negative 277 kilojoules per mole, and I kind of scrunched it in there. And so what we need to do is write the rest of the equation for that. So there I'm showing the elements that make up ethanol, and the only thing I need to do now is go back and balance it so that I have 1 mole exactly on the right hand side. So in order to do that, I'm just going to balance like normal. So for oxygen, let's see, I need to multiply that by 1/2. Carbons, I need to multiply by 2. And hydrogens, I need to multiply by 3. And so now I'm showing the formation of exactly 1 mole of ethanol, and I have 1 piece of my puzzle. If you look at your desired equation, our combustion, our next species on the left was oxygen, and that's an element. So we don't need to write that down because we know that the delta H of forming oxygen from its elements is going to be 0. So we can ignore that and go on to the product side where we have carbon dioxide listed first. And again, looking that up in my reference materials, I see that to make 1 mole of carbon dioxide gas, it's going to release negative 393.5 kilojoules per mole of energy. And I just need to rewrite the rest of my equation. There we go. That one's a little bit easier. So there's my second piece of the puzzle. Now my last piece of the puzzle is water. And so I'm going to again write down my product, 1 mole of water, and write the equation as it's made from its elements using a delta H from a reference sheet. So you pause and try, and then see if you can match it to mine here in a second. Okay, so that's what I got. And again, according to my information, I got negative 241.8 kilojoules per mole for making 1 mole of water gas. So you gotta be careful that you're looking at water gas and not water liquid. And now you have 3 puzzle pieces, and you should be able to go through and use Hess's law to uncover the overall delta H for your reaction. So you're going to go through and reverse things as needed and multiply things as needed. So right away, the first thing that I see is that this first equation here with the C2H5OH is in reverse. So what we're going to need to do is reverse that so it's going the other direction, and we're going to need to change the sign over here from a negative 277 to a positive, and we don't need to multiply because we had 1 mole of the ethanol. Second, carbon dioxide is a product, so we can leave it in that direction. However, we needed to have 2 moles of carbon dioxide, so we're going to multiply that by 2 and everything else by 2, including our delta H value. So come over here and multiply our second delta H value by 2. And then finally, in our last equation, water is on the correct side, the product side. However, there were 3 moles of water created, so we're going to multiply that value by 3, and that means everything else is going to get multiplied by 3. So this is going to become 3 halves, and H2 is going to become 3, and we're going to need to multiply that delta H value by 3 as well. When you do all that, you should then be able to combine your formulas, your equations, combine your delta H's, and get an overall delta H of your reaction. And when you do that, you get an answer, and when you add all of those up, you should get an overall delta H, or excuse me, this is not of the formation, this is for your reaction, of negative 1235.3 kilojoules per mole. So that's how to find your puzzle pieces. So I want you to try another one now on your own, and we're going to talk about it first thing tomorrow. So the example is sodium bicarbonate, and this equation is already balanced for you, decomposes into sodium carbonate, water, gas, and carbon dioxide, gas. So what I would like for you to do is to find the pieces of that puzzle, put them together, and find an overall delta H for that reaction using heat of formation reactions and values. So good luck, and we will try that one tomorrow. All right, have a good day. Talk to you soon. Peace out.